And we're on to number 5. Okay, so question 5 is to, let's not even read the question. So what I always say to students is, if you think you can figure out what you have to do from the picture, then just jump straight in. Okay, it's a great attitude. It's a great tactic. So let's jump straight in. The unknown is marked with the letter X. Okay, so here we have it here. And so it's unknown is marked with the letter X. First is to identify, is it a hypotenuse? It is. So the formula we're going to use has a square root in it, excuse me, and a plus in it. Just had to take a drink there. And so we're going to head straight in with 14 squared and 20 squared. We turn on the calculator here and we'll clear it and square, and we will do 14 squared. You see, it's as if the square root and the squares kind of cancel each other out. That's how Pythagoras works, and it just cuts the corner across. Okay, we'll do an equals to see it in third or radical form. That's an exact, so we have the equal sign, exact value, and then we'll do shift equals to see it in approximate form, and that's 24.41 if I give it to 2 decimal places. Can't move on until I use the unit. The unit is centimeter. Okay, we'll partition our page down here. We'll identify that this situation, this X, is a leg of a right angle triangle. So we're going to use minus in the formula, and this is the hypotenuse. We need to identify it. So X equals the square root, sorry about the noise in the background, 16 squared minus 12 squared. Okay, in comes the calculator, clear, square root, 16 squared minus 12 squared. We'll look at it in third form. I could have used the difference of 2 squares too there, but I'd have had to get 4 times 28, so it's not worth the mental maths, no way. Okay, and it's equal to 4 root 7, and it's shift approximately equal to 10.58. And that makes sense, I'm sure, because it's less than 16. If this was greater than 16, you'd have a problem. Okay, and we'll partition our page and on we go. Identify it as a leg. The leg has the minus. We will go X equal, another thing to look for is, do we know this? Is this a regular common Pythagorean triplet? And it isn't. So we're going X equals the square root of 11 squared minus 5 squared. And if these are just 2 apart or 1 apart, we could use the difference of 2 squares, mental maths, not worth it. Clear, square, big square first, minus little square second, equals, shift equals. So I'm going to truncate because I don't want to round, because rounding takes time. 9, so E is approximately equal to 9.79. I'm truncating. They did say 1 decimal place here, so I will continue on then and say that's approximately equal to 9.8. And I won't go this, I could do 1 dp, but I think it messes things up. And because I've used the approximation and the 1 decimal place, that'll do fine. And I'm saying that it's in centimeters. It's checking across centimeters, centimeters, centimeters. That was question 5. We're on to question 6, and it looks like we're going to do a bit of problem solving. So the first thing we'll do when we're doing problem solving is maybe guess what they're going to ask us. If that doesn't work, we say, okay, come on, let's read it. So this is what I Okay, so I use my little straight edge ruler here for reading, and I got a rectangle. Alright, let's flick it over if we want to find it less distracting. I don't want to get rid of that barcode later on. Okay, let's leave it the way it was. A rectangle is 10 centimeters long and 8 centimeters wide. It doesn't matter because I've had that here, so I don't need to worry about that. I don't have to any underline or anything. It is obviously a rectangle. They should indicate that that's a right angle too. I calculate the length of the diagonal. Now the diagonals are of equal length, so it doesn't matter which one we do. So let's put in this one. Okay, and give your answer in centimeters correct to 1 decimal place. Right. So let's say D for diagonal. Let's identify that it is a hypotenuse. Don't want to spell it out each time, so let's just call it longest side. And give your answer in centimeters correct to 1 decimal place. So we're using the Pythagoras for distance formula, so D equals the square root of 10 squared minus 8 squared. Okay. Now, while I can start doing heroic mental maths, the only thing I'm likely to do is drop marks if I do that. So I'll use the calculator because simplifying thirds and all that kind of thing is really, but the best strategy is to use the calculator. Let your brain rest a little bit. You've plenty of thinking to do in an exam. Okay, yes, it turns out to be 6. I should have spotted it. I'm surprised though. So 5 and 4. I made a mistake, and that's why I'm surprised. So you saw maths at its best there again because I had made a mistake. That's not maths at its best, but I picked it up because I was just a bit surprised. Okay, so sorry. What will I do now? I'll go back and I'll change that into a plus. So even though I had said longest side, I still went and messed up with the minus. So I have to learn from that and try to think, how am I going to improve my methods so that doesn't happen again. Where do I go back again, lads? Forgot. Is it del back 1? Yeah, and plus. And equals first 2 root 41. And shift equals the second thing. Okay, and if they wanted to 2 decimal places, so equals 12.8, and units are centimeters. We're on to 7. We're reading for understanding. Use the given grid to write down, so they didn't. So we can use the grid, which is the supporting triangle, and the supporting triangle here is 9. Take away 2, or count the boxes, you get 7. Let's just double check. 1, 2, 3, 4, 5, 6, 7. The most basic thing of all in maths is counting. 1, 2, 3, 4. So I should be counting, not subtracting. Okay, hence find the length. The length of line segment PQ. Why couldn't they say hence find PQ? The authors do annoy me sometimes. Anyway, we're going to find, so PQ. So we'll say that PQ length, the distance from P to Q is equal to, we're using a plus, the square root of 7 squared plus 4 squared. It's calculator time now. Square root it's equals first, it's shift equals second, it's look for 8.1 is approximately 8.1 not centimeters, units. And bring that up to the exact answer as well, and that's enough. You can only bring it to 2 places, and then we spend less time reading questions and worrying what they're asking, because we're training and getting ready for exams, so we want to answer we want to get into a habit of practicing, so we don't need to we can do more than they ask for. Okay, I think we should look at the picture first. We should tell what's going on here, as in how tall up the wall is it going to be, how high is the wall, H. We should identify that it's a leg, and a leg is a minus. we should get stuck in now and say h equals the square root of 5 squared minus 3.6 squared. No problem putting a square there on your decimal, with your decimal places, no problem at all. Into your calculator, the square root of the exact value equals the square root of 301 all divided by 5. The approximate value 3.469. Give your answer correct to one decimal place. I'll bring the 4 up to a 5. 3.5 meters and meters. Good stuff. We have, because of these two right angles, a trapezium. They're probably going to ask us to get this. Find the length from B to C. Please, 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 why can't you do that? Correct to one decimal place. Okay, so problem solving. Let's understand the question. We understand it. Okay, we understand it already. We're trying to find the distance from here to here. Make a plan. My plan is to construct a right angle triangle here by dropping a perpendicular. Calculate the length from here to here and from here to here. So from here to here, because it's a rectangle, opposite sides of a rectangle are the same. So I can bring that 5 over there, and because it's a trapezium and this is straight and this is straight, 10 take away 6 is 4. Okay, now we go on and say, look, it is the hypotenuse we're trying to get, so it's definitely the plus form of the calculation we're definitely going with. So just to be complete, we'll write the BC again here. We'll write equals the square root, and we have 5 and 4 as the legs. We call them the legs, okay, the leg lengths, the legs of our triangle. We're square rooting 5 squared. We're equaling. We're shift equaling, and it's approximately equal to 6.4. And exact one decimal place. We did great problem solving, didn't we? Super. Question 10. Start here always when you're problem solving. Predict what they're going to ask you. Look. Think, are there are we allowed to say that word anymore? Shortcuts. Think, can you do it by inspection? I can do it by inspection because I understand and I know this triangle so well. It's the second most famous Pythagorean triplet. So from that, I'm going to do it by inspection, which means that the length BC equals 12. And if anyone has any doubts, you can write that. And if the length BC is 12, we'll be able to answer anything else. So find the length of BD, 3. There's probably no other way of doing it. So that was a lot of problem solving. Question 10. Find the length of AD. Oh, BD was 3. Yeah. Find the length of AD. Well, we can do that now with a plus question with the 3 and the 5. Okay, and there's no easy way of doing this, so I need to say that distance AD equals, the square root of 5 squared plus 3 squared, which is equal to exactly equal to root 34 radical, or radical 34 you'll also hear. Square root of 34. Shift equals is approximately equal to. Oh, I forgot to start guessing what the lead is. We'll go back to that very good practice, and we'll go 5.8, and they're all boring one decimal place. Why are they going to only one? 5.8, because maybe that's enough. 5.8 centimeters if it's rough carpentry work or something, but if they want to build something very precise, they might want to go a bit more, especially if they want it to be a right angle and so on. Okay, are we happy? Oh, lovely. This looks like maybe it's a rhombus, maybe it's a parallelogram. I can just tell you one. Okay, I'm going off. I'm just enjoying a bit of maths here. Let's count sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 and 5. So that's at 45 degrees. And this is definitely not 5 and 5. 5 and 5, yeah, nope. Okay, so it's probably a parallelogram. Anyway, let's get into it. Use the grid and the theorem of Pythagoras to work out the length of the sides of the given figure. Ah, yeah, so we actually have to do our helping triangle. You know, it didn't say, so it didn't tell me. So I'm going to come across here. 1, 2, 3, 4, 5. Probably the same though. 1, 2, 3, 4, 5. Yeah. So it's the helping triangle gives me 5 and 5. The other helping triangle gives me. Let's do subtraction here. 8 take away 1 is 7, and we're up 1. Okay. So the square root. I want to show you a trick. I want to show you something here now. Okay, so you have 5 squared and 5 squared, and it's double 5 squared. So the square root of 5 to be squared is definitely going to mean the 5 is coming out. Another way of looking at that is there's a very famous triangle with 1, 1 and root 2. And so if you make this 5 times longer and 5 times longer, it's 5 root 2. So we'd be missing a trick if we didn't apply that special triangle. You still get it right, but you'd be missing a trick. Okay, and that allows us to say that distance AB equals distance DC equals 5 root 2. Of course, I still might want to plug it in the calculator, but I'll plug it straight in at 5 root 2, confident that I got it right, and go straight for a shift equals. Okay. Equals 7.07. Look, I'm not going to 1 decimal place, I'm going to 2 decimal places. The other one then will be distance AD equivalent to distance BC equals, by the way, if this is a 5, 5, this is 5, 5, this is 1, 7, it has to be 1, 7, 1 and so on with the helping triangle. Okay, so we're going square root of 7 squared plus 1 squared square root of 50. Now that's the it's the same. It is even though it's 5, 5 and 7, 1, they're actually the same distance. I forgot that. It's a famous one. 7 squared plus 1 squared is equal to 5 squared plus 5 squared equals 50. So 50 can be written as the sum of 2 squares in 2 different ways. I forgot, because that 50 is 2 times 25. And that's 5 root 2. So it is a rhombus. It is a rhombus. I learned something along the way because I'd forgotten the 7, 1 and the 5, 5. Okay, and it came back to me. So they're all 7 point. And was there a hint in there to work out the lengths of the sides of the given figure? Okay, it's a rhombus. You won't find rhombus in the tables. You will find a parallelogram in the tables. Way up here. Okay, and there's our friend the trapezium. Okay, how are we doing? We've 11 done, we're going on to 12. Okay, so we're going to do all of this by inspection because we should know the 3, 4, 5. Let's actually draw it like a visual for our visual learners. 3, 4, 5 is just with us all the time by inspection. Okay, so if we have 3 and 4, then I can say that that is 5. And the other one that's with us all the time is the 5, 12, 13. I mean, so we can apply both of them by inspection. So I have a hypotenuse opposite a right angle, so y is 12. So I worked out x and y there by inspection real fast. 13, in the given figure, the two right angles are marked. Okay, find the length of sides C and D. Okay, you can go ahead and square up, but again I'm going to say that by inspection I identify this as being twice as big as this. So this is 10. And then this is twice as big as the one with 5, 12 and 13. So this is the equivalent to the 12 side, but it's double, so this is 24. Okay, and you can just do the whole lot and say by inspection. Of course, if you get it wrong, you lose your work of merit, so you want to be very sure of yourself, but you can always come in and go on a question like this and just go a, b, c, c squared equals a squared plus b squared, and you got your work of merit anyway, no matter what. Okay, so we're on to question 14. So first try and figure out what's going on. I think we've seen this loads of times. It's a thing for holding up a banner or something. We have a 20 here, we have an 8 here.